apply. So now, I haven't actually told it to do anything, but then I can tell it to behave that way. Behave off that.
You know, each object has one of those world limit boxes like that where you can select it.
Yep, so you can do that on a per object basis.
So like the paddle would have that big world limit box.
Right. So right now I'm going to do it so the ball doesn't go off our scene. The paddle will still go. I can do that to limit it. Now you can do it. There's some built-in physics options, you know, just for the majority of your games. But you could also do it for script callbacks. So if you want to custom control, you can. And you can custom control the response on a behavior. But let me just get the ball bouncing first. So world limits, it's an option over here. Right now it's off. So I've defined the volume of it, but it's not doing anything. There's a few options here. So these are basically the physics response we want for it. In this case, I want it to bounce. So one useful option is kill. So if you want things to go off the screen, just to die and not render anymore, not exist, you just stay able to kill and you never have to worry about it.
And then in that case, your world limits are larger than your monitor. Is that right? Or
If you wanted to.
where does it?
So
That's
that's
like bullets flying on the screen. You want to track it as bullets. They're out of control.
right. So you'd want that on like all your bullets, things that once it's off the screen, you just don't want to deal with ever again. If you wanted to like keep it, let's say disable it, you would trigger for a custom script callback and not have any of the presets in. So we try to give as much as we can pre-built, but obviously there's a lot of stuff you want to do that we can't predict everything. And you define this parameter here. So right now this outer box is my screen size. So if we look at my world limits, it's just slightly bigger than my actual screen. So I say bounce, and I can define it manually. This is where you can do the callback option if you want to do that. In this case, we don't want it to.
What is the bounce on the
So there's null, which that would be the case where we select callback and we don't want it to do anything. Leave it alone, but we still want the response tracked. And then the callback will pass in which side of the world's bouncing in. Kill just destroys the object. Clamp just does like a clamp collision response, just stops it against it. Bounce gives like a bounce collision response. Sticky, again, another physics type response.
It sticks to the wall.
Right. So it'll just kind of like eat the velocity, whereas bounce kind of interacts with it. Now you can override some of these via your object physics settings as well. So in some cases you want to control this on the object level. Some cases you want to control this on like the world limit level. You don't have to use world limits too. You could use collision values, but for simplicity, for like a game like Breakout, we don't really care. World limits is perfectly fine. So now we want to tweak a little bit of its collisions. So we have some options here. Polygon, for example, that actually allows us to customize the polygon. You can get to the editor by clicking on the object. Now, since this is a circle, there's a pre-built for circle, which is obviously what we want to use here. Superscribe ellipse is an option that would circle around the bounding box itself. And in this case, we wanted to just circle inside the bounding box, which is close to what we want. There's a scale option here. So say our image was actually half the size of the entire volume, we could do 0.5 and the circle would scale to it. In this case, we'll just leave it with default settings. We got our collision response. Right now the ball is just staying still, so we want to give it some velocity. So in this case, I'll give it 25, the X and Y.
Now, what are these number boxes?
The actual numbers?
The number boxes.
Oh, okay, here. So to control the collisions in your game, as well as the rendering in your game, there's collision groups and there's layers. So layers allows you to kind of control the rendering of your objects in kind of like a bin sort of system. 0 is the layer foremost in front of the screen. 31 is the back. So 0 through 31, there's 32 layers. So say you want some objects to render in front of another object. So say we have like projectiles or particle effects, right? And we want those to render over everything. We could put those in layer 0, and we put all our objects in layer 1, everything layer 0 will always render in front of layer 1. What this allows you to do is mask your collision against it. So these are bit masks, 2-bit masks. So you can say this object collides with only things in group 3, or only group 3, layer 3. So this allows you to control your collision, like say all your projectiles are in group 3, all your enemies are in group 5. You set all your projectiles to only collide against group 5, so that way they never hit anything but the enemies, if that's what you want. You can completely customize this. Technically, you don't have to mask your collisions. You could handle the script response in every single case and just do like a check is a player object and not do anything. But when you're getting to optimization steps, you want to really control how many communications there are between the engine and script. So this helps you kind of limit how many times the engine actually calls to script. So in this case, we're not going to really worry about this at the moment, since this is just a breakout game. But when we get things colliding against other things, we may want to control that. So let's fire it up, see if I didn't forget anything. There we go. So, world limit, we set the physics response, we defined the world limit size. We defined it as a circle collision. We could have left it as square as the default, but it probably would have looked as good as it would have. And we gave it a starting velocity. So those things allow us just to get a ball bouncing around the screen with just tweaking a few settings in the editor. Now we wanted to actually do something for a very small platform and a very big breakout ball. To do that, we first need to add some collision to this. We could leave it as its default, which is just like a square that fits the whole thing, basically like a bounding. That's the default. But this is where the custom collision polygon editor I showed you really comes in handy. So we can hit that. And you have to have a convex collision polygon, but it will help you do so. So it'll tell you if you're doing stuff bad for convex. There's an ability for it to kind of fix things for you, like that. But you can't fix things for yourself.
When it's red, that means it's not going to work.
Yeah. Basically saying it's been validated because convex can't go in and on itself for efficiency. But there is this nice little button here, which kind of just takes out all your bad ones. But in this case, we're just going to follow it around. That's a good point, yeah. So some of it comes down to what sort of experience you expect. So we want to trick the player a bit here, but get some more interesting experience. Yeah. True. And that also brings to this point here, kind of slanting this more. So this all comes to like your gameplay design. But the straight side on the bottom, you hit on the side, it's not. You can get in situations where it's not going to necessarily get the results you want. Like hitting on the side, it might bounce down. If you angle it up, it might create a better experience. I mean, again, this is changing things in a visual editor, so you can do whatever you want. But we'll save that. Yeah, this is enabled. So now this comes to some of the collision settings where I was talking about. Now, getting objects to collide with each other. Well, everything you add in the scene is defaulted to layer 0 group 0. Right now, all these are enabled.